Hello everyone and welcome back to Mathematics with Usman. This is the second video in my series on the subtopic of transformation called reflection. And in this particular tutorial, we are going to see reflection in another perspective. And that perspective is reflection using coordinates and matrices. Students, as I told you earlier, the different objectives that we have to attain in this topic are: number one, use the following cases of transformation: reflection M, rotation R, translation T, enlargement E and their combinations. Number two, identify and give precise descriptions of transformations connecting given figures. And number three, describe transformation using coordinates and matrices. In addition to these three objectives, students, there is one more objective that we have to attain is: if reflection of A gives B and the rotation of that B gives you C, then this whole process of two combined transformation will be written as, the second part will be written as R on the left and the first part, which is reflection, will be written on the right. Means R of A, Rm of A equals to C will be used in this particular situation. Today students, in this tutorial, we are going to explore the third objective, which is describe transformations using coordinates and matrices. Since we have started the reflection, so we are going to describe reflection using coordinates and the matrices. As I told you, there are 4 cases of reflection in the last tutorial, whose link I am going to leave in the description box. And we are going to explore all 4 cases, but this time with the coordinates and the matrices. So the first case is the reflection in x-axis. So students, let us first draw the Cartesian plane, in which we are having the horizontal line, which is called the x-axis, the vertical line, which is called the y-axis. Now let us consider any point P lying over here, and its coordinates are 2 in the x direction, 3 in the y direction. Now we want to reflect it in the x direction, so here we are having its x direction. So what is the distance of this point P, vertical distance of this point P from the x-axis? And students, we can clearly see that the distance of P from the x-axis is 3 units above. The reflection of it will be in the opposite direction and at the same distance. So P dash is going to be somewhere here with the coordinates 2, minus 3. Students, if you examine the point P and its image P dash, only change you will see is in the y-axis, and only the sign is being changed. X-axis is 2, P dash, x-axis is 2. In P, the y-axis is 3, however in P dash, the y-axis becomes the negative 5 of it. In general, if I take any point P having the coordinates x, y, if we reflect it in the x-axis, its x will remain x. However, whatever the y coordinate is, you have to multiply it with the negative sign. Now if we consider the matrix for this reflection in x-axis, we will take the matrix 1, 0, 0, minus 1. Because if we multiply it with any coordinate x and y, what we are going to get? X and minus y. So students, you have to memorize the matrix that is related with the reflection in x-axis is 1, 0, 0, minus 1. Let us now begin the second case of reflection, and it is called the reflection in the y direction, reflection in y-axis. We are considering the same point P having the coordinates 2, 3, but this time we are going to reflect it in the y-axis. Now students, again the same process. Consider the vertical distance of this point, which is 1, 2 units. So its image will be in the opposite direction of P and at the same distance of 2 units, where we are having the coordinates of its image x as minus 2 and y as 3. So if you examine these 2 points P and P dash, we clearly can see that there is no change in y-axis, only x-axis has changed and it becomes negative. So in general, we can say that if we are having any point P having the coordinate xy, its image will be negative of x and y will remain unchanged. And the matrix related with this particular reflection is going to be -1, 0, 0, 1. Now let us consider reflection, but this time in the line y is equals to x. So the third case is reflection in the line y is equals to x. So first of all, we have to draw this line y is equals to x, in which 1, if x is equals to 1, y will be 1, if x is 2, y is equals to 2. So this will be a straight line having the gradient of 1 and the y-intercept of 0. Now if we want to reflect this point P in this line y is equals to x, its image will be at the same distance from this line but in the opposite direction. So students, we can clearly see that the image of this point P will be somewhere over here, which is half a diagonal distance from this particular line in the opposite direction, whose coordinates are 3, 2. Now students, if you interpret this 2 points, if P is 2, 3, then P dash is the swapping of the coordinates of P. Students, in general, if we are having any particular point P whose coordinates are x and y, after reflection in the line y is equals to x, you simply have to swap the position of x and y. Y becomes x and x becomes y. And the matrix related to this reflection, which is in the line y is equals to x, is going to be 0, 1, 1, 0. If we pre-multiply this matrix with any coordinates like this, we are going to get y in x coordinate and x as a y coordinate. In case number 4, students, what we are going to do, we are going to reflect the same point, but this time in the line y is equals to minus x. First of all, we have to draw the line y is equals to minus x, where if x is 1, y is going to be minus 1, means that the line is having the gradient of minus 1, but the y-intercept of 0. So this fall as we move from left to the right like this and cuts the y-axis at the origin. Now students, let us consider the point P, which is having the coordinates 2 and 3. If we want to reflect this point P in this particular line, we have to consider the distance of this point. And this is the straight distance of this point P from the line y is equals to minus x. Its image will be in the opposite direction and at the same distance from this line. So this will be P dash in this particular case, whose coordinates are going to be minus 3 in x position and minus 2 as y. Students, if you examine the coordinates of P and P dash, you will come to know there is a swapping of the coordinates as well as the sign reversal of the coordinates. So in general, if we want to reflect any point having the coordinates x and y in the line y is equals to minus x, we simply have to swap their positions as well as we have to change their signs. So P xy will becomes P dash, whose coordinates are minus y and minus x. If we now consider the matrix, then we have to simply put the negative sign to the matrix of y is equals to minus x. So its matrix will become 0, 1, 1, 0. And this brings us to the end of today's tutorial. I hope it will have some value to your mathematical concepts. As always, thank you very much for watching Mathematics with Usman. See you in another tutorial. Till then, it's goodbye.